Hello everyone, we are team here and our project is called the McMaster Climate Resilience Hub. Our idea focuses on building a safer, greener and more climate ready campus at McMaster University. Since climate change is already affecting communities in many ways, we wanted to create a solution that helps McMaster prepare for these risks in a practical and long-term way. The problem we focused on is that McMaster is becoming more vulnerable to climate risks. Because of changing weather patterns and McMaster's location near Cootes Paradise, the university faces several environmental challenges. These include flooding from extreme rainfall, urban heat island effects, stress on infrastructure from freeze-thaw cycles, and biodiversity loss in nearby ecosystems. So, the main question we asked was how can we help the McMaster community adapt, prepare, and thrive in the face of these climate risks? We are faced with this question, why does this matter? This problem matters because climate risks are not just future issues, they are already affecting campus life today. They can impact safety, comfort, daily routines, and the overall campus environment. Another issue is that many current responses are reactive, which means action often happens only after damage has already happened. There is also still a lack of awareness and preparedness among students, staff, and the community. If we do not act early, both environmental damage and infrastructure damage will continue to increase over time. To address this problem, we created the McMaster Climate Resilience Hub. This is a campus wide initiative that combines three main parts in green infrastructure, early warning systems, and community engagement. The idea is to help students, staff, and the community prepare for climate risks through smarter campus design, better communication, and shared action. Our goal is to transform McMaster into a living laboratory for climate adaptation and resilience, where the campus not only responds to climate challenges but also becomes a model for how universities can adapt in the future. That is why our solution is not just about reacting to climate problems, but about building a campus that is ready for them.
Now I'll go over the key features of our solution. First, we propose bioswales and wetland buffers, which help redirect stormwater using natural filtration. This reduces flooding and protects nearby ecosystems like Coots Paradise. Second, we include living roofs and an expanded green canopy. This helps reduce the heat on the campus and improve air quality. Third, we introduce a community early warning system that provides real time alerts to the students as well as the staff about climate risks, allowing them to respond more quickly. Finally, our solution uses an equity centered design approach. This means we considered all groups on the campus and include input from local and indigenous communities to make the solution more inclusive and effective. Our solution combines three main approaches to climate adaptation. First is informing and raising awareness through alerts, education, and communication. Second is anticipating and repairing, which includes early warning systems and preparedness planning. Third is protection, which focuses on green infrastructure and ecosystem restoration. By combining all these approaches, we create a more complete and effective solution rather than just relying on one method. To develop our idea, we used the innovators method from the textbook. This method follows a structured process: insight, problem, solution, business model, and scaling. A key idea from the textbook is that innovation involves managing uncertainty. Instead of trying to plan everything in advance, we focused on testing and refining our ideas step by step. This allowed us to reduce the risk before finalizing our solution and ensured that our idea is realistic and impactful. The first step in this method is developing insight. We observed that climate risks on McMaster campus are increasing while awareness and preparedness are still limited. The next step is identifying the problem, which the textbook refers to as the job to be done. In our case, students and staff need a way to stay safe during extreme weather, understand climate risks, and respond effectively. So, the core problem we identified is that the McMaster community lacks the tools and systems needed to properly anticipate and respond to the climate challenges. This understanding helped guide the development of our solution. For our solution, we started with a simple idea. The textbook calls this a minimum awesome product. It was focused on infrastructure improvements like managing stormwater and reducing heat. As we developed it further, we realized infrastructure alone would not fully solve the problem. It can reduce physical risks, but it does not help people stay informed or prepared. So we expanded it into a more integrated system that combines infrastructure with awareness and early warning systems. We compared three approaches. One was infrastructure only, one was awareness only, the third was a combined system. The infrastructure only approach helps with flooding and heat, but it does not guide people on how to respond. Awareness only approach improves understanding, but without physical changes, it does not reduce actual risk. The combined approach worked best. It addresses both physical risks and user awareness at the same time. This follows the idea from the innovator's method. We focused on learning through testing different options instead of making assumptions from the start. We also made an important change during the process. This is called a pivot. At first, we focused mainly on flood management because this is one of the most visible risks on campus. But after looking deeper, we realized climate risks at McMaster are broader. They include heat, infrastructure stress, and damage to surrounding ecosystems. So we expanded our solution into a full climate resilience hub. It addresses flooding, heat, and ecosystem impacts together instead of separately. This makes the solution more complete and more useful in real world conditions. Overall, it helps reduce climate risks across campus. It protects ecosystems like Coots Paradise, which are closely connected to the university. It also improves long term resilience by combining physical systems with awareness and planning. In addition, it encourages community driven adaptation where students and staff are actively involved instead of being passive users. Our project stands out for a few key reasons. First, it is feasible. It uses proven green infrastructure methods that are already used in many cities. This makes it realistic to implement. Second, it is innovative. Instead of focusing on one solution, it combines environmental design, technology, and community involvement into one system. Third, it is scalable. While it is designed for McMaster, the same idea can be applied to other campuses or even the wider Hamilton area. Finally, it is sustainable. It supports biodiversity, improves environmental conditions, and avoids creating additional harm. These factors make our project both practical and impactful. This project was a team effort. I worked on structuring the solution, organizing the slides, and helping shape the overall presentation. Ishan helped coordinate the project, contributed to research, and supported the development of our main ideas. Aranya focused on researching climate risks and helped develop the adaptation strategies used in our solution. Throughout the project, we worked together through discussions and feedback to refine our ideas. This collaboration helped us build a more complete and well rounded solution.